Hey guys, and welcome to a new tutorial. Today we are going to show you how to create some platform mechanics in the project Breeze that we introduced a while ago. And by we, I mean Josh, our very own and legendary support engineer, and me, who's going to be really quiet while listening to Josh's tutorial. If you are, by the way, new to this series, you might be wondering what you are currently looking at. We made a cool little game project called Breeze and introduced some parts and pieces of Breeze to you in the live streams. You play as a small robot dropped somewhere on a low-poly island, trying to find fuel to fill up a rocket and return from your vacation. During our original stream event, each mechanic in the game was introduced one at a time, including some commentary from our resident developer experts at Crytek. So this time you are going to learn something about the actual game mechanics that were written in C++. So buckle up and let's go.
My name is Joshua Nuttall. I'm a support engineer here at Crytek, and today we have the fun stuff. Today we're going to do gameplay mechanics. This is going to consist of a few mechanics. So first of all, we have picking up collectibles, in this case gas canisters. We're going to have collection zones, which will, when you pass into the zone, will take the gas canister off you and put it on a pedestal. We're going to have falling platforms that when you stand on them, they will fall from beneath your feet. And we're going to have bouncy platforms. And the way this is set up is we're going to have a few mechanics that are standalone components in the world. And for example, the bouncy mechanic is going to be an extension to the player component. So this should show you both ways of adding new mechanics to the game. First of all, we're going to start with the falling platform. This is just because it's quite an easy component to make. And it shows you some important concepts that we need to get out of the way for this video. So, first of all, we need to make a new file or a new class. Normally in C++, you would right click here, do add and class. Due to how CMake works, this isn't really going to work. So what you would normally do is add new item, set the one you want, give it a name, and make sure your path is the project, code, and components. But the way I prefer to do it is in the file explorer. I normally take the spawn point, copy and paste it, and rename it. So in this case, falling platform. If you then open up the CMake lists.txt and add these in, so spawn point becomes, you add a new one called falling platform, and same for the CP. Save that and close. In this case, I don't want to save. Then you go to the root of your project and regenerate the solution. And just regenerate. Then you can open up your solution again. And you should see the falling platforms has been added to the project. This is my preferred way of doing it because I find this is more consistent. But what you can also do is when you've edited the CMake list, you can build this zero check project. And what this will do is cause CMake to rerun and reload your project. The reason I don't do this personally is I've had some issues with it not fully reloading the project before. And this is just by nature of how CMake and Visual Studio interact. You can use both ways, both work, both do exactly the same thing. Just pick the way that works best for you. Doing it through Visual Studio is less steps, it's a bit smoother, but may incur issues if adding things to the project manually. Okay, now we have our files. So we have fallingplatform.h and fallingplatform.cpp. You see at the moment, it's just a spawn point. So for now, let's just remove all the spawn point code, but keep this std.afx. And for the header, we're going to remove all the code and just keep the pragma ones. For the sake of your project, you might want to remove the copyright and add your own. Just something to note, Okay, now we have two nice and clean files to work from. So what we do next is we need to create our component. So we're going to make a new class, and we're going to call this C falling platform. C standing for class, being part of the Cryengine standard programming style that we use. You don't have to enforce the C prefix, but it's just best practice. And this is going to extend from identity component, and the access is going to be public. Oh my god, I can't spell today. Try that again. The access is going to be public. There we go.
This works, yeah.
Yeah. And it's going to be an identity component. So we have a little class there. You see, identity component is red because it's not defined. So we need to do some includes. So in this case, we're going to include cry entity system identity component. And you see the error goes away. Something else that we're going to need for this class is a previewer. So we want to be able to preview this item in the world when we're doing the editing. So we're actually going to add a ifdef for this because we actually don't want this to be in the final game. We only want this to be in the editor. So if we do ifdef release and just end that. So this set of code will only run when we're in release. And this is going to be a public entity component previewer. Now we need to move on to actually constructing the class. So we want this to be public, and we need a constructor. So C following platform, and we need a destructor, but the destructor has to be virtual. So virtual C following platform. We're not going to do anything with the destructor, so for now just set it to be default. Then something else we need is the reflect type. So static void reflect type. And in this case, we can use autocomplete, but we need to change this type description to be the class name. So C following platform. Some important things that we need to do here. So first of all, we need to give it a GUID. So des.setGUID, which is a string followed by underscore cry underscore GUID. Now the string is what needs to be a GUID, and the best way to generate this is if you go to tools, there is a create GUID tool, which will look like this. And the one that we want is number 4, the registry format. I like to click new GUID a few times to make sure it's unique. Copy it, and you can just paste it into the string and save that. And the line. Next, you need to set a editor category. So when you're creating the component, this is the category it will be shown in the components window. So this would be set editor category. And we're going to call this category game for now. So all your game stuff would be in the same category. Next, you want to do a label. So set label, and this would be what it shows as in the game. So falling platform. So when the designer creates the component will be called falling platform. Next, let's add a description. So set description. So this would be the tooltip that's displayed when you hover over the component, and this is useful for making sure designers and artists and stuff understand what the component is intended to do. So for this, I'm just going to give it a simple name. This platform falls when the player lands on it. Make sure you use proper English so people can understand what you're doing. Next, let's add some component flags. So same thing, we do set component flags, and this takes an array of component flags. So the first thing we want is identity component, e-flags, and we want the transform flag. And what this does is make sure that the component that we're creating has a transform to it. Next, we're just going to follow some standard setup. So we want another flag for the socket. And as you can read on the tooltip there, it allows other components to be attached to the socket of this component. This means we can attach things to sockets on here. And then we need one more, and this one's called attach. Similar to the socket, but in reverse. This allows this component to be attached to other sockets rather than other components attached to this socket. And for now, we're going to leave that one there. We're going to come back to this later to add some values for people to edit, but for now, this is good. Next, we need the initialize. So create the initialize. This is going to be a override. So identity component has an initialize function. We're overriding that behavior. Next, we need the event mask. So try entity event flags, and this will be called get event mask. This is constant and is also an override. Now we have the events, we need to process them. So void process events, and this takes a constant s entity event and just call it event. And again, it's an override. That's s entity event events. Good practice to make sure you get things right. As you saw before, I inherited from the component when we are not in release. So the implementation of this needs to be the same. So when we're not in release, so make sure that's if and def, not if def. Let's move the comment. And for this, we want 3 functions. So first one is a virtual entity component previewer, and that's a pointer, or get previewer. It's good practice to make this on final, and this just returns this. Nice and simple. Next, we want another virtual, this time void serialized properties. And this takes a serialization archive, and we're just going to call that archive. Just for best practice and be that final. We don't want to extend from this. And one more, but this one is the most important one. This is the vendor. And this takes in a constant identity reference, a constant component reference, and an entity preview context reference. And this would be const and final. Okay, that's all the functions we need for this class. Next, we need some variables. So having done this in advance, I know what variables we need. So we're going to make a schematic gym file name. And it's going to call this m_geometry. You'll see that gm file name doesn't exist yet. So we go back to the top and we add some more includes. In this case, we need cry schematic, and this would be resource type.h. And you see the error goes away. So that's the geometry. Next, we need another schematic type. This time we're going to do material file name, and this is going to be underscore material. This one is partly optional, so if the material is attached to the geometry, then it will use the geometry as material. But adding a material slot lets you override the material that you use, which can be useful for many cases. Next, we're going to have a floating point for the time until we break. So underscore time until break. Add a bool briefly colliding with the player. So underscore collided. Spelled correctly? Yeah. With player. And finally, a vector free for the trigger size. And that should be everything we need in the header file, which is nice and simple. Next, we go to the CPP file. And there's some important stuff we need in here. So first of all, we need to include a header file. Next, we need to define the player because we need to use it in here, but it doesn't exist yet. So class C player component, let's end that. Next is one of the more important things about the component system is we need to register the component, essentially. I've seen many people not do this and then the component doesn't exist within the editor. So you want static void register falling platform component, and this is going to be a schematic I environment register, I environment registrar, can't pronounce that very well.
Don't look at me neither, Josh, me neither.
Registrar.
Registrar.
Yeah, that one.
I can say it in German if you want to. Maybe that would make more sense. Registrar.
It just registers things.
Yeah.
But RARs at the same time.
Yeah. It's a crazy one.
Yeah. Create one of those. Next, create schematic. C environment. Registration. Scope. And this is going to be registrar. And scope. And we want to do iEntity get entity scope UID. Just end that line. And for this, just create a region. So you notice there are some missing types here. So let's include these. So you want to include cry, schematic, environment, iEntity registrar, and include cry, schematic, environment, and then this one is going to be environment registry. Next, you want to do schematic, C environment registration scope again. For this time, it's going to be the component scope. So do scope dot register, and there's a little macro for this. So schematic make environment component, and you just give it the component name. So in this case, C falling platform. And then if you use to deflect any functions, it would go in here. So you see there's another error for missing type. So in this case, we want to include again cry schematic, this one is going to be again in the environment, under environment, elements, and then environment component is what we need for this one. Okay, now we have that. We now need to actually register the function. So there's a macro for this as well, which is cry static auto registration function. It needs to pass a reference to your function. So in this case, I'm just going to copy and paste the name because it's quite long. And that work. See, there's another missing type. Okay, see, it's got an error that's not defined. So we need to another include. In this case, include cry core static instance list. And see, once that's included, the error goes away. So after you have the cry auto register function, next we need to implement the functions you made, and then we can test an engine to see if the component worked. So first let's start with the constructor. C-fallen platform, C-fallen platform. Next we need the initialize, so void C-fallen platform component initialize. Then let's do the get event mask, so C-fallen platform get event mask. The type for this is cry event flags, and the type of the function is const, and this needs to return something, so for now we're just going to return the update event. Event and then update. Now you need to process the event, so void C-fallen platform process event, and then finally we want the if and def release, and in here we have void C-fallen platform render. Yep, and make sure that that is const. With all that done, we should now go to build, which is Control-Shift-B. We go to the top and do build. Once that's done, make sure that you start up as the editor and run that. Now we're in editor, let's go into the level. And what you should now see is under components, there's a game section and there's now fallen platform. If we drag this in at the moment, it does nothing. It's just a component that's in the world. Oh, I always keep doing that. You see there's the component in the world, and it doesn't really do anything. There's no properties to it. It's just there. So next, let's actually add some behaviors to it. So close the editor and go back to the code. Let's start with, in the header file, let's start with exposing some of these properties we made. So we want to do des.addMember, and this is not a particularly complex one, but is a general pattern we're following. So first you pass in a reference to the member variable that you want to expose. So in this case, let's start with C-fallen platform geometry. You need to give it a small unique ID, which can be no longer than 4 characters long. So in this case, let's do geom. Okay, in this case, let's do geom. It's worth mentioning that this unique ID is unique to the class and not unique to all classes. So it only has to be unique for this reflect type. Next, let's give it a name. So in this case, geometry. Give it a label. Again, geometry. And then you give it a description. Geometry for the platform. And then finally give it a default value, in this case, nothing. We don't want a default value. So we want to do the same with the material, the time until break, and the trigger size. So we're going to fast forward through this part because it's very repetitive, and we're back when it's done. Okay, now we've created these member types, what we can do now is compile again and launch the editor. And we open up the level. And what you see now is when we add the component into the level, it has properties on it. But you see at the moment, if I add some geometry to here, so for example, let's add a platform. So falling platform, you see it does nothing. There's no visible platform that's created here because we haven't implemented the code for it yet. We just exposed the parameters. So let's move on to actually having it do stuff. The reason we're all here. Let's start with just setting some default parameters for a few things. So we want to do time until breaks, default that to 5. Trigger size, spec 3, and collide with player, do that to false. Then in the initialize, now let's load some geometry. So what we're going to do is _p entity, and this has a lovely little thing called load geometry. In this case, we want to do slot 0, and we just want to do _geometry dot value. Things to note: the geometry in slot 0. So if you want to automatically assign the slots, you do -1, or you can manually assign the slot for geometry yourself. So first of all, you see we assign it to slot 0. If there's already geometry in slot 0, this will override that geometry. If you want to auto-assign the next free slot, you can do -1. And the load geometry will return an integer of the slot that it's assigned to. So if you do -1, it will assign you a slot, and you could do slot like that, and this will become the slot that it's assigned to. In this case, we know that this is the only geometry, so assigning to slot 0 is not a problem. And then you just pass in the geometry value that you want, and this is just a path to the resource you're loading. Next, we have the geometry. Next, we want to add a material to it. So material pointer, and let's call this p material. This one's a little bit more complex, so you want to get the global environment. You want to get a 3D engine, and there's a material manager. So get material manager, and in here we can load material. Similar kind of thing. We just want to pass in the material value. Delete those extra brackets. And in this case, then we need to pass in a buffer if we want to create the material if it's not found. In this case, we don't. If the material doesn't exist, then that's it. We don't care. But if it does exist, we're going to load the material onto the slot. So we want to get the entity again. And we do set slot material. And we want to do it in slot 0. And we're going to do p material. So in this case, we load the material. If it exists, we just assign the material to whatever's in slot 0. In this case, our geometry. Okay, now we have an object rendering in the game with a material, but you won't be able to interact with it at this point. So let's go on to actually adding physics to the object. So in most cases, the geometry you're loading will have a physics mesh attached to it. This tends to be imported from your asset creation tool of choice, whether that be Blender, Maya, Max, or whatever. You create your physics mesh and import it alongside your asset. And we're just going to reuse this existing physics mesh by default. we just need to physicalize the entity to ensure the physics engine is aware that the component and entity in question should be physics enabled. So what we need to do is create a S entity physicalize params. I'm just going to call these physics params. And on these physics params, there's a few things you want to set. So first of all, the type. In this case, PE_static. And this just means that it's going to be a static mesh. There's loads of physics types, so you can have rigid bodies, living, which is characters, rope, soft bodies, all that kind of stuff. But in this case, we only want the static. And next we need to do the physicalize params dot slot. This is going to be the slot of the objects that are going to be physics aware. In this case, you want all slots to be physics aware. So just do -1. So it physicalizes all the slots in the entity. In this case, there's only one object in slot 0. Okay. And finally, if you access the entity again, it has a function called physicalize, and it just takes your physics params. With that, it's now physics aware. Now that it's physics aware, we want to be able to actually have a zone of interaction. And there's a lovely little component in the engine that helps you with this called the trigger component. And we're just going to create one. So first of all, we're just going to create one. So entity trigger component, and it's going to be P trigger component. P entity, and this is going to be create component. Type is going to be I entity trigger component. So we're using the entity to create a new component on it. Next, we need to create some bounds for this. So this is going to be a constant, so it's not going to change the initial setup. Create a new bounding box. Trigger bounds, and it's going to be a ABB of trigger size, but we're going to divide it by, times it by -0.5, and by trigger size times 0.5. So we create the ABB, and we set the minimum location and the maximum location. So this is just the trigger size times by -0.5. So we just create this ABB and set a minimum location and maximum location. You can work out the minimum location by taking the size of the box and times it by -0.5. And then you can work out the max size of the box by taking the size and times it by 0.5. And what this does is it adds the minimum and maximum to the origin of the bounding box. So if you had a bounding box with the origin and you add half the size, you end up at the top corner, or the top far corner. If you add -half the size, you end up at the bottom near corner, for example. And that's just simple math when creating the bounding box to work out where it should be. Now we have our bounds. We want to do the trigger component, and we want to set the bounds of the trigger component and just pass in those bounds. That's all well and good. Now we have a component that has some geometry, has a material, it's physicalized, and has a trigger. There's a few little things that we want to do. So currently, if we make changes to this entity in the inspector, it doesn't actually change anything. So what we want to do is register another event, and this one is going to be cry entity event, and this is editor properties changed. So there's another event we want for entering the trigger. So when we walk into the trigger's volume, we want an event to say that this has happened. And the engine already has this for us. So there's cry entity event, and entity entered this area. So these are 3 events are pretty much everything we need. So what we can do is let's start with the entity into this area event. So what I'm going to do to make this easier is I'm going to make a switch statement and just pass in event.event. So we can switch through all the events that we have in this scenario. And in the case where we have a cry entity event entity entered this area, let's add some behavior to that. So first of all, we need to get the entity ID for the entity that's entered this area. So we're going to have a constant entity ID, and this is going to be the entered entity ID. We're just going to do a static cast for this. So static cast, and we want to cast to entity ID. And the thing we're casting is the event has a m parameter at location 0. And this is the entity ID in location 0. So you can find out the parameters of an event, where if you F12 over it, or F12 the event, you'll see a list of all the parameters for each event. So for example, the entity area event has 3 parameters: entity ID, area identifier, and the entity identifier. In this case, we only want the entity ID. And what we're going to do next is we're actually going to get the entity for this. So this is going to return a entity pointer, and it's going to be the entity. The way we do this is get the global environment, p entity system, and we use get entity. And what we can do is pass in the entity ID for this, and this will return us either null if the entity doesn't exist, or the entity if it does. So next we need to check to see if we actually got this entity. So if entity would be if the entity is not null. But we also want to make sure that we're colliding with players. So what we can also do is, now we know the entity is not null, we can do get component and check for a C player component. So if the entity exists and it has a player component, then in that case it's going to be the player. So we can set this mCollide with player to be true. And that's all we need for that event. That's nice and simple. Next, let's handle updating editor properties. So in the case we get the event for editor properties changed, this is a really simple one which we want to initialize. Also remember, after every case, you want to break. This is just to make sure that you don't run into the next case when you don't intend to. Okay, so editor properties changed, we just reinitialize the component, which will reset the material and the geometry, rephysicalize, and update the bounding box. That's simple. That's everything we need. Next is one more event that we need to manage, and this is actually going to be having the platforms fall when we stand on them. So we know we've collided with a player at this point. Next, we need to handle what happens when we do this. So for this, we're actually going to use the update. So cry entity e event, and this one is going to be the update event. Remember to break after the case. And this event is going to, first one is the delta time, so const float delta time, and this is going to be the event. In this case, we want a fparam 0. So if we check the definition of update event, first one, we see fparam 0 is the frame time, and if the time until break greater than 0, we want to do time until break minus equals delta time. So in this scenario, we've collided with the player, we have some time left until we're falling, so just subtract the time that's passed since the last frame from this. So this would be essentially decreasing in seconds. So over the course of a second, the time until break will go down by 1 second. Of course, frames don't necessarily update on the second. They update like 60 times a second or maybe 40 times a second, depending on your frame rate. And it would just, between frames, the time that's passed is subtracted. So we just subtract the delta time from it. So if we're in theory running at 1 frame a second, every second we subtract 1. When at 60 times a second, we subtract 1/60th of a second every time we hit this. Now we've done that, we want another if check in here, and this is going to be if the time until break is less than or equal to 0. Well, in that case, it doesn't matter if we collide with player, so collide with player equals false. So then do vec3 new position equals m_entity m_p entity get pos, which will get the position of the entity, and we want to change the z component of this. So new pos.z minus equals 10 times delta time. So we want to move 10 units every frame essentially. And now we have the new position. Let's do set pos, and we just set the new position. Trying to think. Yeah, that's all fine. So now, what's happening here is when we entered the area, we set that we're colliding with the player. Then on the update, when we're colliding with the player, and there's a time until break, we'll just subtract from that time. There's one problem with this that I see at the moment. So if on the update, if we collide with the player and the time until break is greater than 0, we just subtract the current frame time from that time. When it passes below 0, we just move the object down by 10 units every frame, or every second. So we move the object down by 10 units a second. One question that might pop up here is, where is this time until break set? We don't do it in the update, we don't do it in the entered area. Well, this is actually set from the editor. So remember when we exposed the parameter, time until break? This was done with 5 seconds as its default. And we defined it in the constructor, again, 5 seconds. So by default, time until break is 5. So every time we collide with the player, it sets this, subtracts down in 5 seconds, it then falls. Once it's fallen, the current setup of this doesn't have a way to reset it other than resetting the game. Now we have the behavior done, let's add a quick way for us to preview everything in the editor. So we added this render function. This only happens if we're not in release. And what we want to do is if context dot be selected. So in this case, if the object is selected, I want to make a matrix 3-4, and this is just the slot transform, and this is just going to be get world transformation matrix. Now we have that, we need to make a object bounding box, so OBB, call it OBB, and it's going to be equal to OBB, create OBB from ABB. a lot of acronyms here. Pass it in a matrix 3, 3. And this is the identity matrix, so identity. And next we need to pass in an ABB, which we already calculated up earlier, so we can actually take that calculation and reuse it. So you just copy this and paste it in here. Now we have an object bounding box. We actually want to render this object bounding box, so the engine is nice in this regard. It provides us with a nice little thing to do this. So we want to access the P renderer, and we want to get the auxiliary renderer, which is used for debug. So get iRenderer auxgm, and this has a built-in function for drawing. So draw OBB, and all we need to do is pass in the OBB, the transform of it, whether it's solid or transparent. In this case, let's make it transparent. And then you need to pass in a color. So for this, I'm going to do context, debug draw info, color, and a draw style. So in this case, it's going to be BBD, and we're going to do faceted. You can F12 on this, and you see the options. So we have faceted or extreme color encode. For now, just faceted would work for most things. It's quite a higher level topic to cover, so we're not gonna cover that here. But with that, we have the following platforms done. So what we can do now is build and run that. P static is undefined. Okay. Defined. There's a few little things here that are not actually reporting issues, but will actually cause issue that we need to define. So we need a few more includes before this will work. So first of all, let's include physics, and this is going to be physics interface, and one final one for the auxgm renderer. So include, this time it's going to be Cryrenderer, auxgm renderer, and I could build that now. All works. We run the editor, and under levels we open up a level. We then place down a component, and you'll see it has a bounding box to it. If we add some geometry to this, so we're going to add the falling platform. And you see there's a falling platform. Let's move that over here, where we can jump on it. Time to break is fine. Let's set this to be 5 by 5 by 5. One thing to note is the geometry is created from the origin of its root. So in this case, the root of the geometry is not centered. I believe falling platform 2 has a centered root, as you can see. So the root geometry is centered on this. Therefore, when we place it in the thing, it's aligned with the bounding box. So let's give this a test. So if I play the game now and land on it, you see after 5 seconds have passed.
Ooh, I've been waiting for this test so long. Let's go.
It falls to my feet. Nice and simple mechanic. So what we can do is, if we create a few of these, we can jump across them and get to another location. So we're going to jump from one to the other. Oh, then you missed that one.
Show me some of your jump and run skills, Josh. I need to see them.
You see, I managed to get to the last one before they all fell. That's quite a simple mechanic. So with these, we can make a quick path to the bouncy platforms that allows us to test the next mechanic. So we'll come back when we have these platforms set up for testing, but you can do the same on your side, and whether that makes sense for your game. So just put these in a position that I can jump across them. Okay. Camera back. Okay, so that wasn't supposed to happen. It fell after the game stopped. Okay, now set up the level. There's a small bug that I actually want to show how to fix. So you see, in this case, if I move it, this one falls. This is because a rare chance of when you leave the game and the timer hits 0, it changes to be colliding with the player and falling despite you not being in the game no more. And this is quite a simple fix. So if we go back to our code, make sure you've saved your level, go back to the code, you can stop running, and on the initialize, the next thing you want to do is the collide with player, set it to be false, and that should resolve that issue.
And now you should be able to create your falling platforms on your own. If you do so, please let us know what you came up with on our official Discord server, or let us know in the comments down below. 2 more videos are about to be released in this regard because we have 2 more mechanics to talk about. We have the bouncing platforms and we have the pickup area zone. So stay tuned for more. Thank you, Josh, for this awesome tutorial, and I will be talking to you guys in the... Wait, you have to give me a thumbs up. You have to give Josh a thumbs up for this amazing tutorial, and if you do like this video and you are new here on this channel, please subscribe for more videos like this so you don't miss any. Thank you, and check the video description down below. There are a lot of links that you can follow and you can click on, because I've heard you guys click on things. So do it, please. Bye bye, guys.